Hello again and welcome. This time I'm going to talk to you about the digital input and digital output. What is a digital input or a digital output? Well, usually we need to receive information from the environment and I need to send information. Usually this is control information for maybe a motor or a light display diode in order to show that my program is working, or maybe to the liquid crystal display, or I need anything. I need to show the information to my user or to the environment. So when this information has digital values, it means 1 or 0, true or false, yes or not. Usually this information is called a digital information, and of course it can be an input or an output. So a digital input is information that the environment sends into my program, and it can be true or false. For example, if I am pushing this button, yes, I can be pushing this button, or no, I cannot be pushing this button. So this is a digital input, yes, and my digital output can be the control for this light emitter diode, or LED for short. So this LED can be turned on or cannot be turned on. So this is a digital output because it's information that my card sends to this LED. Yes? So how do we use this kind of inputs and outputs in my programs? Well, this is really easy. First of all, I want to do it easier to understand. So I use this int. This is to declarate a variable, an integer variable. Yes, I can use the number of the ports. Look, I am using the port 0 and the port 1. So easily I can use port 0 and port 1 in my program, but I want my program to be intuitive. So instead of calling port 1 and port 0, I want to call the port 0 as the LED, because the port 0 it's controlling the LED. So I said, okay, from now on my port 0 is going to be called LED, and from now on my port number 1 it's going to be called pin button, because I want my program to be intuitive. So that's why I am using these instructions. Now, in my program I need to specify if this port is going to be used as an input or as an output. So I told you before that my port 0, that now it is called a LED, it's going to be an output because this port is going to control the LED. So I said, okay, pin mode, I need to specify the number of the port, and as I told you, I could be using the number of the port in here as 0, because that's the name, the original name of the port, but I changed the name to LED to make this more intuitive, so I can write here 0 or LED. And as I told you, I want this port to be an output. The same for my input, that is the pin button. Again, I could write here 1 because it's the port number 1, but I changed the name. From now on, my port number 1 it's going to be called pin button. So LED it's my output and pin button it's my input. Okay? Now, in my program, I want this program to start over and over and over. So inside of this void loop, I write first this instruction again. You see, it's the same as this instruction, and I am using this instruction to change the name, or actually to declare a name. Yes, I want to declare the state of my button, that is digital read. This instruction is going to read this port, the port number 1, as a digital input, and this instruction is going to read the state of this. So it's going to read 0 if it has a 0 voltage value, or it's going to read 1 if it has a 5 volts digital value. So this is also again to make my program more intuitive. Now I use this if condition, that is the same if that you know already, and so I ask, okay, if the state of my button, as I told you, this instruction check the data in this pin, and if it has a 5 volts level, it's going to be read as 1. So if this state is 1, okay, turn my LED on. And in the other condition, if it has no 5 volts, it has 0 volts. So I don't need to specify if this state is equals to 0. It's obviously, if it is not 1, of course this is 0. So it is going to turn off my LED. You see, high 5 volts, low 0 volts. So if I push the button, my LED receives 5 volts, and if I get a 0, my LED gets a 0 volts. And before we start checking this program, I want to show you some things about my circuit. First of all, these elements, actually only this element, needs a electrical source. It needs a power. So I need to provide this electrical power, and for this I can use these pins. You see, I have these pins with 5 volts because all this card has all the electronics needed to provide this power. So with all these elements I have a connection in here, and now this pin can be used to power my electronical devices. So I use this pin to provide power to the plus line. You see, all these green holes are electronically connected. So if I connect 5 volts to this, I'm going to be able to get 5 volts in this and this and this and this. And also because I am using this red wire to connect this with this, now I have also 5 volts in all of this. So the same goes for the ground. The ground is the reference, the 0 volts. So I connect this ground to here, to the minus line, and again I have ground or 0 volts on all these holes, and the same with this wire, I have 0 volts or ground in all of this. Okay, now look at this. As I told you, my 0 pin, it's the pin used to control my LED. So I connect the 0 pin to my LED. Yes, I connect it to the anodes. This is the positive connection for my LED. As I told you before, these LEDs, it's like a diode. It has to be connected properly in order to work. So I connect the output of my card to the positive, and I need to connect the negative leg of my LED to the negative or the ground connection from my board. And look at this, I am using this resistance. I told you before that we need to control the current in my electronic systems, in my electronic circuits. because if I don't control this current, my elements can be damaged, it can burn, and in sometimes it can explode. So this resistance is used to control the current in this little circuit. Actually, it's to control the current in the LED. Yes, so you know, you have the skills, you have the knowledge to calculate the value for this resistance. Actually, it's 313 ohms, but I am sure that you can calculate this value and check that this is the proper value for this resistance. And now, as I told you, my input is the pin number 1, this pin. And as you can see, I have this button that is like a switch. When I click this button, I have electrical connection from this to this. And when it is not pushed, the button, there is no electrical connection from this to this. So when I click this button, the positive voltage, the 5 volts, comes from this wire, and it comes through this button to this, and then it goes to this, to the pin. Yes, and so the card receives the information from the environment. But look at this, I have this resistor and this connection. And this is because digital inputs only can receive 5 volts or 0 volts. You cannot get another strange value. You should not input another value, for example 4 volts or 3.3 volts, etc. No, you need to be really clear. 0 or 5. So usually when you don't push this button, this connection it's free. It has no specified value, and sometimes light bulbs or computers or electronic devices irradiates electricity, and so you can get electricity in these electronic devices. You can receive this electricity from the computer, from the light bulbs, even yourself. Sometimes you can produce this, and so all this electricity floating in the air gets it's received in this part of the circuit, and so you don't have 0 volts. You have, for example, 1.1 or something, and so this card get confused and say, okay, you are sending 0 or you are sending 1, but it's not, I'm not sure, and so this start working really strange. It makes weird things. So we need to be careful to be sure that if there is no 1, if there is no 5 volts, there should be 0 volts. So that's why I use this resistance to connect 0 volts to this. And this resistance is big enough in order to prevent that when I push this button, I get a short circuit. When I push this button, electricity comes from this to this, and then of course it gets to this. But because we have a lot of resistance here, the electrons rather to go to this cable, to the uh, to the pin. And when I don't push this button and I have electrons moving around in the air, and these electrons get to this and get in this connection, there is a bigger resistance in here because this is not working, so these floating electrons goes to this, and so this is the way to ensure a 0 value when I am not pushing this button. This is really important for you to remember, and you need to be sure when you are using digital inputs and you don't have a proper digital value, you need to be sure that there is a 0. So connect this input to ground using a relatively high resistance, so when you don't push this button, this 0 signal goes to the card, and so the card works properly. So now let's see how this works. So start simulation, nothing happens. If I push the button, the LED lights on, and when I stop pushing, this turns off. And as you can see, it takes a while to turn off. That's because of the simulation. Don't worry, it's not a big deal. But as you can see, this is working properly. So now uh, we know how to specify to change the name for the ports, and we can specify if this port is an input or an output, and now we can control elements using outputs, and we can receive information using inputs, digital inputs. Yes, of course there are another kind of inputs. Actually, there are analog inputs and analog outputs, but we are not learning this today. So I guess that's it, and have a good day.